Hello, welcome to Fundamentals of Acoustics. Today is the last day of this week, which is the 11th week of this course, and what we plan to do today is extend our discussion on loudness. And yesterday specifically we had discussed the idea of loudness level, and we stated that the unit of loudness level is fons. Today we will introduce a new concept, which is loudness itself. Loudness. And first I wanted to illustrate how is this different from loudness level. So consider three scenarios. One is that there is a bird and it is chirping at 70 fons. Okay. How do we know that it is 70 fons? We say that it is 70 fons because if I play a sound 1000 hertz sound at 70 decibels, people will say that this sound is as loud as this bird. So it is 70 fons. In the second case, we play a drum and it is playing at, let us say, 95 fons. Okay. And in the third case, we have a locomotive engine at 120 fons. Now, based on the discussion earlier, we know that how do we get to these numbers. We know how we got to 120 fons, we know how we got to 95 fons, and how we got to 70 fons. But can I say that drum is 95 by 70 times louder than bird? That we do not know. We have not explained that if the difference is 25 fons, how louder is the sound A versus sound B? I can also not say, or for that sake, locomotive engine is 120 by 70 times louder than bird. I cannot say that. But perceptually, if you ask that, oh, is this sound louder than this sound? Not only the person says yes, it is louder, but he will also, if he is careful enough, he will also say, yeah, it feels maybe this sound is double, twice as loud as this sound. Those statements people do make. So what is this factor? Is this the right factor or is this a wrong factor? It turns out that the answer to both of these questions is no, because these are wrong factors. So even though we know how to calculate fons, I just cannot take the ratios of these two fons and say that sound A is X times louder or softer than sound Y. Okay. So loudness scale helps us relate, to sounds loudness levels. This loudness scale, the loudness scale is measured on a scale called SON or SON. Okay. And if I can convert this fons into sons, then I can relate two sound sources. So how do I do that? So what people have done is they have done a lot of perceptual experiments, and people have found that each time loudness level goes up by how much? 10 fons. Sound's loudness is perceived to have what? To have doubled. Okay, this is important too. So this is, how did I say that? This is based on a lot of perception experiments. So you play a sound at 10 fons and then you play a sound at 20 fons and you say, what do you think about these two sounds? So a lot of times people say that, oh, the sound has doubled, loudness has doubled. Okay. Then you play it at 30 fons and then they say sound loudness has gone up by a factor of 4. Each time you go up 10 decibels, it goes up by a factor of 4. So with that understanding based on perception, people have crafted a SON or SON level, and this measures the loudness, and here you can compare. Okay. So our reference SON level is what? It is 40 fons, they correspond to 1 SON. Then 50 fons becomes, they correspond to 2 SONs. 60 corresponds to 4. Yeah, you are right, 4. So each time it goes up by a factor of 2. So in general, I can write it as n equals 10 to the power of ln minus 40. This is a formula, into 0.30103. Okay, and this is equal to, so if I, what is 10 to the power of 0.3? What is log of 2? 0.3 or 0.30103. This is actually log of, okay. So this approximates to 2 ln minus 40 divided by 10. So in an approximate sense, I can say n equals 2 to the power of ln minus 40 divided by 10. Let us explain this relation, where n is what? SON level and ln is FON level. So using this formula, if I know ln, I can calculate n. Okay. So now with this understanding, let us answer these questions. So what were the, so bird was at 70 fons, then we had drum, it was at 95 fons, and then train, it was at 120 fon. We can calculate their SON levels. So for bird, n is equal to 2 to the power of 70 minus 40 divided by 10. So that comes to what? 2 to the power of 8 SONs. Here n equals 2 to the power of 95 minus 40 divided by 10. So that is equal to 2 to the power of 5.5 SONs. So you can calculate these numbers, and in case of train, n is equal to 2 to the power of, oh I am sorry, this is 70 minus 40 is 30, 30 divided by 10 is 3, and here it is 120 minus 40 divided by 10, so is 2 to the power of 8 sounds. Okay. So, how loud is each sound with respect to other? So, engine is 2 to the power of 8 divided by 2 to the power of 5.5, and that comes to 5.66 times louder than what? Than the drum. And the drum is 2 to the power of 5.5 divided by 2 to the power of 3. So, this becomes how much? 2 to the power of 1.5, and that is still 5.66. I have just picked up numbers so that these ratios are same. So, drum is 5.66 times louder than the bird. So, in this way we can compare two sounds, and we can say that sound A is x times louder than sound B using the Son scale. But to compute the Son scale, first we have to figure out the Fon scale, and Fon scale we can figure out if we using those equal loudness contours, we can figure out the Fon scale, because all we have to do is first we have to see what is the decibel level for the sound. From that decibel level and a particular frequency, we can compute its Fon level. Once we know the Fon level, we can compute the Son level and we can compare two sounds. But all this works 2.5, so it may be 2.5, okay. So, but all this is based on a premise that the sounds have only single frequency, right. Only then we can do these comparisons. Now, if the sound is having a lot of mixed frequencies, then all this approach does not work. Then we have to go to some more advanced methods, which we will not cover in this lecture. So, all this approach works only if we compare monotonal noise. What does that mean? That if the noise has only single tones, then we can compare sound A versus sound B and do all that. But if sound has all sorts of noises, then things become more complex. So, that concludes our discussion for today and also for this week, and I hope you have learnt something useful over this week, and we will start once again next week, which will be the final week, and till then have a great day. Bye.